Hello everybody and welcome back. Root Beer here with question number 8 on our 2016 Euclid contest. Okay, so I've got my pen ready and what have we got for question number 8? So here it is, it's a two-parter, all written, and if you haven't given it a try, I would strongly encourage you to do so. But what have we got? So A part, in the diagram, ABCD is a parallelogram. So these two sides are parallel, as are these sides. Point E is on DC with AE perpendicular. They've shown that to DC. So we got a nice little perpendicular there. And point F is on CB with AF perpendicular to CB. So right angles there. We're told AE is 20, AF is 32. And the cosine of EAF, so this angle in here, is 1/3. Alright, determine the exact value of the area of quadrilateral AECF. AECF, there we go. Okay, so let's draw this picture again. I think with the right angle triangles, it's not too bad in order to plan how we're going to figure this out. Because if we could just figure out most of these lengths, I mean, we've got what is this? A, E, this one's F, B, C, D. I'm pretty sure that was the order, right? Yeah. Because if I can figure out AE and then DC, then I'll know the dimensions of the parallelogram. And what we want is this, this sort of lopsided shape. Well, that would be the parallelogram minus the two right-angle triangles. So very easy. I just need to figure out the lengths, and I figure that's probably where the hard part's going to be. All right, now they gave me the cosine, which immediately makes me think, oh, I should probably use a cosine law. So we got this angle up here. So one thing that's crossing my mind is perhaps figure out EF, because I do know that we got 20 here and 32 here, and I can figure out EF using the cosine law, because I know the cosine of this angle is 1/3. Whether or not I want to do that, I'm not entirely sure, but it's certainly something that immediately springs to mind. I just don't necessarily see how EF is going to help me out. Wish I knew more about these triangles here. Because yes, I know AE is 20, but how can I figure out AD or DE? If I knew DE, I could figure out AD, of course, Pythagorean identity, but just knowing one side length of a triangle is not enough to help, and I've got one side length each. So perhaps we should go hunting for angles instead. Now, the sum of the angles inside a quadrilateral is 360 degrees, just like the sum of the angles inside a triangle is 180 degrees. So 360 degrees is going to be, well, let's write it this way, just because it is a written response that we have to give. So we'll say AEC, but I know that's 90 degrees. ECF, which I don't know. CFA, again 90 degrees, and FAE, which we're told is, well, which I'm calling theta, so I actually should probably say that. Because I know the cosine, I don't actually know I could grab my calculator to figure it out, but it's not a nice thing like 20 degrees or something like that. So I'm going to say let angle EAF be theta. So this is 90 degrees, and then another 90 degrees, and theta, well, the two 90s are 180, so we get 180. When you subtract that from 360, is angle ECF plus theta, so ECF is 180 degrees minus theta. It's just what's left over here. But this is a whole corner of my parallelogram. And one of the nice things about parallelograms is opposite angles are identical. So that tells me this whole angle here is also going to be 180 minus theta. But, again, using the same sort of 360-degree logic, you can also say that the sum of the two angles on the same side has to add up to 180. So we can get theta here, and that, I think, is a better place to use cosines, because we're inside right-angle triangles. I'm not saying there can't be a way where we use the cosine law to figure out EF. It's just EF isn't the most helpful thing for me to be working with. I suppose, well, you can figure out EF, and then knowing all three sides, you can figure out the area of AEF, but you'd also have to then figure out the area of EFC. And I much prefer my plan of parallelogram minus the two right-angle triangles, especially now considering I've come this far. So we'll say something like, then we can see ADC and ABC is theta. I don't have to, I mean, as long as it's clearly labeled on our picture, we're good to go. Okay, so turns out both of my right-angle triangles are similar, and they got a theta here. We get a 90 minus theta here. But because I know the cosine of theta, so you use SOHCAHTOA, I guess. So cosine is adjacent over hypotenuse. So this tells me the ratio of the sides. And the 32 and the 20 are opposite the theta. So, we can say this, since cosine of theta is 1 over 3. So then I can see that AD over AE is 3 over 2 root 2, but I know AE, they told me that in the question. It's 20. So I can figure out AD. Similarly, we can say 1 over 2 root 2 is DE. Yeah, DE. Yeah, DE. So I can use both of those to figure out 30 over root 2 is equal to AD. And 10 over root 2 is equal to DE. Which I guess we can simplify. 30 is 15 times 2, so 15 root 2. And then DE is a third of that, so 5 root 2. And you can show the work again, but you could say similarly, since it was AF is 32. So it's still divide by 2 root 2 to get BF. So 32 divided by 2 is 16. 16 over root 2, so that's 8 root 2. And then the other one, AB, should be 24 root 2. So now if we go back to our picture and take a look at what we've got, I have 24 root 2 here, so I'll get 24 root 2 down here. I've got a base of 5 root 2 here, and a base of 8 root 2 here, height of 32 for this triangle, height of 20 for this triangle, and so we should be fine. So the area of, it was A down to E, then C, then F, is the area of the parallelogram. Let's call it ABCD, minus the right angle triangle AED, minus the other right angle triangle ABF. And so that should be, so you need the base times the height for a parallelogram, so that's 20 times 24 root 2. 1/2 base of 5 root 2 times height of 20. And then the base was 8 root 2. So 1/2 8 root 2 times 32. And this should be our answer. So there's a lot of root 2's here. So we'll just keep those around. So 480 root 2. 2 and 20. So 50 root 2. 2 and 16. So 128 root 2. So 430 minus 128, so that would be 310, so 302 root 2. I'm just going to double check that on my calculator. 480 minus 50 minus 128. Yep, 302 root 2. So that's going to be our answer to 8A. Oh, we still have 8B to take a look at. It's a little different question. Sometimes with 8, 9, or 10, the whole question can be related. Usually question 10 follows this pattern. Not so much for 8, but every once in a while. But it looks like we have a very different question here. Determine all real numbers x greater than 0 for which log base 4 of x, so it's a logarithm question, minus, log base x of 16. I'm going to have to use the change of base formula here. Equals 7 over 6 minus log base x of 8. So the thing that struck me, which I said while reading the question, is the change of base formula. So if you have, it's useful to know these sort of log rules. If you've got log base a of b, you can change that one logarithm into 2 logarithms with a base that you choose. So c, using this rule here. This is called the change of base rule. Okay. It's useful. I mean, it's a good idea to know all your logarithm properties because, well, logarithms basically just boil down to their properties and how they are the reverse of exponents. But I find because they're taught so late, people tend to be afraid of logarithm questions, and you really shouldn't be. There's only like 4 or 5 properties to know, and if you know them, you're good. Okay. So, what do we got? Log, it was 4 of x, but then it was x16. And then I think the last one was x8. Just double check. Okay. I'm a bit more comfortable when the unknowns are inside the log function, so. And I like the log base 4 of x, so what I'm going to do is I'm going to trade this to log base 4 16. And then log base 4x. Log base 4 8. Log base 4x. Okay. So now we can multiply both sides by log base 4 of x. Because that, well, I suppose no, x can't be 1. I was about to say you can't multiply. You have to check to see whether it's 0. But no, that's dividing. So we can multiply both sides by log base 4x. And actually, what we might want to instead do is, because we're going to get a quadratic, what I'm going to do is I'm going to say let y equal log base 4 of x. Then, what have we got? Well, we've got y plus, well, 4 to the what is equal to 16? 2. So we get 2 over y, and suddenly this doesn't look so scary anymore. 4 to the what is 8? Well, 4 cubed is 64, square root of that is 8, so 3 halves over y. Yeah, that should do it. So now if I multiply through, I'll get y squared plus 2 is 7/6 y minus 3 halves. I'm actually going to multiply through by 6 on both sides as well, just to get rid of all the fractions. So minus 9, and now we've got 6y squared minus 7y plus 21 is equal to 0. And now it's just a quadratic. So I'd expect 2 values of y. They might both translate into 2 values of x. They might not. Remember, you're only allowed to put positive numbers inside logarithms. But what can we do here? So, do I have to use the quadratic formula? I feel like I might. Yeah, I can't think of an easy way to factor this, so we'll say y is equal to negative b plus or minus square root of b squared minus 4a... Oh, I don't like this. For AC all over 2A. This doesn't seem good. 4 times 6, that's 24 times 21. That's way too big. So are there no solutions? Oh, I copied it wrong. It's a minus sign here. Oh, I'm sure somebody out there was screaming at the page, at the video the entire time. Minus sign's there. That should help me. Make that a minus sign. So this is a minus 2 and a minus 12. Maybe that's why I was having so much trouble factoring it. Or maybe it still is not nice to factor. So minus 12 plus 9, this will be minus 3. So if this were to factor, I'd probably want a 2 and a 3. And we'll say minus 3 plus 1. So I'll get the minus 3 there. Minus 3 times 3 is negative 9. Plus 2 gives me the negative 7. Right? Yeah, that looks good. Okay. So then, where do we go from there? So that tells me the y is equal to negative 1/3 or 3 halves. Yeah, 3 halves. Okay. But then that tells me that log base 4x is negative 1/3 or 3 halves. And then, well, undo the logarithm expression. So 4 to the minus 1/3 or 4 to the 3 over 2. So 1 over the cube root of 4, which I guess we can leave like that. Or 4 to the 3 is 64, square rooted is 8. Okay, now, having done all this, one, double check. Does x satisfy everything? Can I plug it back into the expressions and it all works out? 2, if you've got a calculator, you can probably double check that these expressions are really real. Okay, so if I just ignore everything I've done and go back to the original expression, and do something like, all right, log base 4 of x. So try 8. So log 8, log 4. And so what I'm doing on my calculator, because my calculator doesn't have a log, you get to choose the base button. Some do, some don't. Is I'm using this change of base stuff. I'm just using the ln button. You could use the log button, but I did ln 8 divided by ln 4, and that does the same thing. I get 1.5. Then minus ln 16 divided by, what are we doing? X is 8. I'm testing x is 8. So I got negative, or no, not negative. I got 1/6. Okay. And so 7 over 6 minus ln 8 divided by ln 8. Isn't this fun watching me do this? And I also get 1/6. Now I can just quickly double check. Is the 4 to the negative 1/3, does that work? So 4 to the power of negative 1 over 3. So 0.62, I'm going to store that. Actually, how do I store on my calculator? Okay. 629960,525. So ln of that. Oh, that didn't seem to be the right button. Oh yeah, ln, I pressed ln of it. Divided by ln 4. And I get negative a third. Okay, good. Means that I'm pressing the right buttons. Minus ln 16 divided by ln of recall. And so I get 5 and a sixth. Okay. And then 7 over 6 minus ln 8 divided by ln, once again, press the recall button, 5 and a sixth. All right. Everything seems to work out. I obviously wasted however much time it took me to press all those buttons there. And you might not want to do that. If you're confident in your calculation, of course, don't do that. But I had the time at the end. I just wanted to make sure before I moved on to question number 9 that I did have it right. And that's what we're going to do right now. So we're going to move on to question number 9. I will see you for that in the next video. Until then, take care and have a wonderful day.